We're going to look at special right triangles. These triangles are really important as you move on in math, specifically in pre-calc and in calculus. So it's really important that you get a good foundation of what exactly these are. So these are the two general triangles. You definitely want to have them written down somewhere. With a 45, 45, 90 triangle, looking at this second one, both legs are going to be the same length, which makes sense because it's an isosceles triangle, so both legs should have the same length. And then the hypotenuse relates to the legs by whatever one of the legs is. It's the leg and then times the square root of 2. And you could find that pretty quickly by doing the Pythagorean theorem, but that's what it ends up giving you. Let's look at this first example. We want to find A and B. We're given that two of the angles are 45 degrees, which means this third angle has to be 90 degrees in order for all of the angles to add up to 180 degrees. So we have a 45, 45, 90 triangle, which means we're going to look at this triangle. Both legs are the same length. So if this leg is 15, then this leg has to be 15, which makes this one 15 radical 2. A couple examples that are a little bit harder. Number 2, we have 30 degrees and 90 degrees. That would make the other angle 60 degrees. So we have a 30, 60, 90 triangle. So we want to look at this general triangle. What I would do is label the general sides of the triangle. So across from 30 degrees is x, and the other leg is x radical 3, and the hypotenuse is 2x. So the only information that we're given here for the side lengths is that this side is 12. So if this side is 12 in the specific case, but it's also 2x in the general case, then let's set them equal to see what x equals. So if x equals 6, this side is still 12, but that would make this side, that makes this side 6, so d equals 6. And then also because x equals 6, side c would have to be 6 radical 3. I would do the same thing for this other triangle. If we have 60 degrees and 90 degrees, this has to be 30 degrees. And I would label the side across from 30 degrees, remember, is x. That's our shorter side. And then the longer side is the side across from 60 degrees, that's x radical 3. And then the hypotenuse of the 30, 60, 90 triangle is 2x. So we're given with this specific triangle that this side is 9. So let's set 9 equal to x radical 3. This one's going to be a little harder. Let's say that 9 equaled x times 3. Well, you're multiplying by 3, so you divide by 3 to both sides. Same thing here. We have x times radical 3, so we need to divide by radical 3 to both sides. You don't want to leave a radical in the denominator. Multiply the top and bottom by whatever the denominator is, so that's going to be a square root of 3. So now when we multiply across, we have 9 square root of 3 over square root of 9. Square root of 9 is 3, so that's 9 square root of 3 over 3, and 9 divided by 3 is 3, which means this side is x, we said, so f must equal 3 radical 3. And this side we said was 2x, so e must be 2 times 3 radical 3, which is 6 radical 3.